on the textbook, it's the following, and I'm going to show you the situation. So you have a person who is launching a mass or a ball with an initial velocity of 20 meters per second upwards. So a speed of 20 meters per second from a height of 50 meters. All right, so that's this, okay? So that's the initial height. So given that situation, the first question is asking you to find what's the time needed for the ball to reach maximum height. Okay? So, Pare, you want to find the time to reach maximum height. So solve for that while I finish taking the attendance and answering some questions here, okay?
Professor.
Yep.
So
Yep.
so basically you're trying to find the time that it reaches down the ball. That's what we're trying to find for A.
No, no.
Like how long
Part
does
A
it
is
take to
asking
reach
you,
down?
so it's several questions. It's asking you, what's the time for the ball to reach maximum height? Then you want to find the
Oh,
maximum
okay.
height. Then you want to find the time to reach the ground. So it's a multiple choice, it's a multiple step problem,
Okay.
right?
Okay.
Professor, for the equation, would you be doing average velocity over the acceleration, which is gravity?
To find the time,
Yeah.
now you want to use, you see I put a hint here? Use that.
Uh-huh.
Use that. Use an equation that requires final and initial velocities. Because you're looking for time and you know the acceleration of gravity. Okay, I think I got everybody. Well, let's open this quiz. Oh, it was Trishna. To build it again, I think. Let's see. Everybody saw my announcement about the quiz, right? So you're gonna stay on Zoom while you're taking the quiz. That way I can proctor you while you take it because I'm not using Lockdown browser. And that way you can ask questions as well.
Is the time 2.04 seconds?
Yeah, 2.04 seconds. Yeah. Now what's the maximum height?
What formula did you use for this?
What was that?
What formula should we be using? Are we using x is equal to VIT plus one half acceleration times squared?
Yeah, you can use that for the maximum height. You can use that.
No, for the time, I mean.
For the time, no. For the time, you want to use, okay, so let's solve party. B final equals to B initial plus or minus gravity time. Because the B final at the maximum height is 0, so 0 equals to 20. Since the object is losing speed, minus 9. You know what? Just use 9.8. That's what they use in the book. So just 9.8, don't use 9.81. Keep it like that. 9.8 time. So when you solve for time here, you get 2.04. So that's the time to reach maximum height. Okay?
Okay.
Always use the easy equation or the most simple. For the maximum height, though, that's when you can use y equals to v initial times time plus or minus 1/2 gravity times square, where y is this. That's y. So the maximum height is y plus 50, right? Now, the initial is 20. Time, you found it. What do you use? Plus or minus? Again, since you are going upwards against gravity, you use minus. So 20 times 2.04 minus 1/2. Yep.
70.41.
This y?
70.41. The maximum height 70.41. 70.
Is that y or is that the total?
That's the y.
40 minus 5, 4. Wait, 40 over 220, 20. No, 70 is the total. Y is 20. Right? How much you get just for y, for this?
Yeah, for y, I got 20.4. Yes.
Yeah, 20.4. So 20.4 meters. So the maximum height, you can put like that, H max. That's 50 plus 20.4. That's 70.4, right? That's 70.4 meters. Okay, so is that clear for everybody? It's similar to a problem we did yesterday. I'm also looking at the chat, so you can ask questions there if you want. It's good? Okay. So then you want to find the time for the ball to reach the ground. So the ball goes up, isn't also the question for this? Yes, but since we are looking at distances and you are going in one direction, it matches the displacement in this case. So this and the displacement when you go up are the same, right? If you take all into consideration up and down, that's when it changes. So that's what you have to be careful. But since we were analyzing only the motion going up, then yeah, distance and displacement are the same in this case. All right. So the ball goes up. That's what we analyze. Now we are going to go and look at the free fall. What's the time? Because this is the time to go up, right? Up. How do you find the time for the ball to reach the ground? You want to find the free fall time. So how will you solve for time in that case? Hmm? So what do you need to find the time the ball took to reach the ground?
We would use a position formula, but starting from the total height. So what was it, 50 plus the additional height that it went up that we saw for? Was that 20?
Yeah, so you can put H, the H max is the initial times time, but what's the initial for the free fall?
Yeah.
0. So it cancels out. So you stick with 1/2 gravity time square. And we did this yesterday. 70.4 is 1/2 9.8 time square. Okay, so what's the value of time now for that? What's this time? It should be about 14, about 3.5, 3.6 seconds, right?
Wait, isn't Rowdy pulling it down, so wouldn't it be negative?
Huh?
Wouldn't it be negative if Rowdy's making it go down?
Well, technically, since it's speeding up, you can keep it as positive, but if it's negative, gravity is negative, right? And it's going down, they both are negative. The direction of motion, that, and gravity. So
3.8 seconds. That's what I got.
how much?
3.8. You might want to check the math though. I just want to be sure.
No, yeah, I mean, you can tell 70 divided by 10 is 7 times 2, 14. The square root of 14 is about, yeah, that's fine. It's fine. Yeah, again, so yeah, if gravity is negative, which is because it's going down, the value of the height, the direction of motion is also negative, right? So both negative cancel, so you stick with positive values. All right.
Gotcha.
So we have 3.8 seconds for the mass to on free fall and 2.04 seconds when it went up. So the time to reach the ground, the total time, is how much? It's about 5 seconds, right? It's 3.8 plus 2.04. So 3.84, and if you're required to round in proper sig figs, it will be 3.8. So about, this means approximate 3.8 seconds. All right? So that's another classic example of free fall. Okay, what's going on here? Okay. Any questions?
Yeah, really quick on the bottom, did you add those two together, the total time?
Yeah.
Oh,
Down
okay,
and up.
because you put 3.84, but it should be, was that a 5? Sorry, I just wanted to make sure because I was a little confused because you kept the same
one?
number. Yeah, is that a 5?
Oh, wait, that's a 5. Yeah. Sorry.
Okay, but you are adding them. I just wanted to confirm.
Yeah.
Wait, can you go over
Right.
how you got 3.8 seconds again, like from the before?
So the 3.8 is the time for the ball to go from the maximum height all the way down to the ground. Since the ball is traveling more distance, the 70 meters, it takes more time than when it went up.
Okay.
So the free fall distance is 70.4 meters. And since the initial speed or velocity is 0, so this factor cancels. So you stick with 1/2 gravity times 1. And if it's about the math, so let's put it here. So here basically you multiply by 2, right? Like 70.4, you multiply by 2, you divide by 9.8, and then you take the score. That's 3.8.
Oh, okay.
Okay?
Okay.
So it's similar to the one we did yesterday. The one we did yesterday was when the ball reached the same position. But here it's not because the person is on top of a building. So the ball goes up and then goes all the way down to the ground. So it's this situation here. Okay? Okay. The other situation that I want to go over is this. And that's from here. Okay. So it's a question from the assignment. I changed some of the numbers. Okay. So you have a person throwing 2 stones. The first one at 1 meter per second. The second one at an unknown velocity. Technically negative 1 meter per second. And yeah, basically, the first question is asking you how long after you throw or release the first stone did they hit the water. Now, it says here that both of them reach the water at the same time from the same height. But she throws the stones 1 second apart. That's why I drew here 2. This one goes first, 1 second after this one. All right? So how long after the first one does it hit the water? Okay, so let's explain the situation. Gravity is making the stone accelerate downwards. And how do I get from this equation, right? We have this equation, y equals to v initial times time plus or minus 1/2 gravity times square. Now, here you have to be careful because the problem is asking you to indicate the direction with the sign of your answers. And that's for velocity. Its time is not negative, right? It cannot be negative. So since you are throwing the ball downwards, the initial velocity is -1. So how do I get this? Because like I was explaining, since you're going downwards, the y value is not 48, but it's -48. So -48 is -1 times time. Gravity is going down minus 1/2 gravity times square. But look what happens though. Negative, negative, negative. So you can change everything to positive. So everything goes 48 equals to 1 times time plus 1/2 gravity times square. Okay, that's how you get this equation. All right. So you have a quadratic equation here, which is here, by the way. Right? You have gravity over 2. Actually, I multiply the equation by 2. Why? Because if I multiply by 2, look what happens. 48 times 2 is 96. This becomes 2t. And why do I multiply by 2? So I can cancel this 2. So plus 9.8 is gravity, t squared. And on the left, I wrote the quadratic formula. You need that because look what you get. You get 9.8 t squared, right? The quadratic factor, the linear factor, minus 96 equals to 0. All right, so you have to solve for time using this. Is that clear? Any questions?
Would you have found the velocities first and not done the quadratic formula? Does that work too?
Yeah. So what's your A, B, and C here? All right, guys, that's algebra 1, right? What do you put for B, A, and C?
Wait, I had a question before we move on, if it's okay. So you said that the height is 48, and we're given that in the question, but at the same time you said they threw the rock, right? Then don't we have to find the total height that the rock fell?
The total height is 48. Both of them are at 4. Well, I change it to 48 to keep it easy. They both rocks, both stones are launched from 48 meters.
Oh, is it because it says that she throws the 2 stones vertically downwards?
1 second apart.
Like she throws a stone because didn't you say when we're doing the free fall thing in the previous question we calculated how much the stone was thrown or whatever was thrown, you have to
in this question right here.
Yeah.
In here, the initial velocity was 0. But here, the person is throwing. It's like you are throwing it downwards. So you are giving it an initial speed, velocity. So it doesn't start from rest.
Oh, okay, got it.
Okay?
Yeah, thank you.
So that's why you have this factor now. Okay, so -2 plus or minus square root of b squared minus 4ac, but c is negative, so it will be plus 4, 9.8, and 96, right? Divided by 2 times 8, that will be 19.6, right? 18, yeah, 19.6. All right, did anybody solve 4 times? What do you get? You have 2 solutions. Come on, guys, what do you get?
3.03 and negative 3.23.
So you get 3 point what? 3.03?
Yeah. And the next one's negative 3.23.
So you just take the positive. So this one, and you say negative 3.23.
23.
Okay, so you don't take this, you take the positive. Let's see. Because I'm getting another answer there. Take the positive. Yeah, 3.03. That's the answer. 3.03. Yeah. So yeah, that will be the time. And that's the time that both hit the water because it's a single splash. So even though the second stone was thrown 1 second later, they hit the water simultaneously. So that's why question B is asking you, what's the initial velocity of the second stone? So that is what I want you guys to think. The second stone is going to be launched with some V. It's also going to travel 48 meters. It's also going to be dragged down by gravity. And you already know it's going to take a time to reach the ground, to reach the water, of 3.03 seconds. So who can tell me what's the initial velocity? Easier.
Wait, wouldn't you subtract 1 from the seconds?
No. Oh, wait. Yeah, wait. What do you say here? Yeah, so let's minus 1 second. Yeah. Yeah, you're right. So it will be 2.03 seconds. That's for a second stone. You're right. You subtract 1 because it's 1 second apart. Yeah. So logically, it will be a greater than 1. It has to be faster than the first one. Okay, what equation you use, guys?
I'm not sure if I'm correct, but I used velocity final equals velocity initial plus or minus gravity times the
No,
moment.
you don't have the final velocity. Do you have the final velocity?
Wouldn't it be 0 though?
No. That's a misconception. when you throw something towards the ground, the final velocity is not zero. It reaches with some velocity. And I'm going to explain that in the next chapter because that's a misconception. Yeah.
We still use the same formula, right? Y equals to V initial times half G times T squared.
Yeah, I think this is what you did. Right? Is that what you did? Are you so for me?
Yeah.
Yeah, that's what you use. Because you have time now, you have the acceleration of gravity, and you know the height. So yeah, that's what you use. Let's do step by step. Okay, so this. Caramba. So this is 28. Oh no. 27.8. Okay, 27.8. This minus that. 2.03V. So V is this divided by this. 13.7. Way more than the previous one. Look how much more, right? The difference. Just because of the 1 second delay. Makes sense if you think about it. Try to replicate that in real life. It will take way more effort. Think in terms of like the amount of force that you need to exert. So you match one stone with the other one. Right? Is that clear? Okay, so how will you write the answer though? Because this is the magnitude, this is the speed, but it's going down. So velocity-wise will be negative 13.7 meters per second, okay? Why? Because it's going down. That will be the velocity vector. All right? Just like this. Questions? Okay, so
wait, sorry, so for the last one, it was negative. We have to flip the answer to be negative at the end.
yeah, you have to write negative here because it's asking you to indicate a direction.
Okay.
So when you write the answer on Cengage, you have to put a negative. If it was an exam in class and you leave it as positive, I'll give you all the points because in the exam, I'm looking at how you use the equations and if you understand the problem. And if you get this value, I know that you understood what's happening, right? Yeah. Okay. So here is a misconception. What was the velocity of each stone when they hit the water? So it's not zero. So both stones, one that starts at 1 or negative 1, and one that started at negative 13.7, they both are going to hit the water with some velocities. What are those? Okay, let's discuss what equation will you use. By the way, I
So
hope that
we are,
you guys saw this. Huh?
so we are just looking for velocity final, right, for both the stones?
Yeah.
Okay.
Yeah. And today I sent this in the morning. Is the official formula sheet from the department. So you can use that from now. You can print it and bring it to class. So this is what you can use, right? So which equation here will you use?
The VF equals to VI plus AT.
Yeah, you will use that, right? Good. So for the first stone, what's the acceleration is gravity. So BF for the first stone was the initial, the speed initial of the first stone, the speed is 1. So 1 plus 9.8. And what's the time for the first stone? 3.03. Okay, so what do you get? You should get about 31, 30 something, 30, close to 31 meters per second. That's just math. What do you get? 30.7? Yep. All right. Wow, that's the magnitude, right? In centigrade, so this will be negative 30.7 because it's going down the vector. And then for the second stone, I'll let you guys do it. That's basically what you have to do in that question on the assignment, okay? But it's the same equation, but your VI now will be 13.7.
Can you explain why is it negative? Because if gravity is pulling it down, wasn't gravity positive? So how come the velocity
Yeah.
is negative?
So the magnitude is positive. That's what we get. But the direction is still going down. So since the velocity is still going down, yeah, like
Okay.
here, you right here, negative 30.7.
Okay.
All right. Okay, so for the second one, I think you guys can do it, but that's your 2 examples on freeform. I know you guys have, I have another example here I want to go over, but is there any questions about this? You're good? Okay, so the other example is this. Maybe some of you have seen it already. That's from the book. You have an object that is at rest 3.5 meters from the ground, and you have another object moving at 12 meters per second, constant, from left to right. At some point, they're going to meet. Now, they won't meet unless there is a given distance between the first object. There's a certain horizontal distance between the second object and the first object. Right? So this object is going to move certain distance, and this object is going to fall, and they're going to meet. The problem is asking you 2 questions. Find the value of x. So find the distance x. And the second question is find the time it takes for the object to fall. All right, that's a nice question for you guys. Let's see how you do it.
Wait, what's x again? Which distance is it?
Is the distance the second object is moving for them to meet.
Oh, okay.
So, are
Yeah.
they falling perpendicular of each other?
Yeah, one is going horizontally, one is just going vertically. And this is constant, okay? 12 is constant, no acceleration on the x-axis, just here because of gravity. So think, it's I don't know, maybe you guys have seen this in the past. It's when you have more than one object now.
You would do the height formula and find the time it would take to fall. Then after you do that, you would set it back, the 12 meters per second object. You would set it back by that same time based on its speed.
Okay. Yeah, that's what you do. Very good. So I got an answer here from a student. The student got 10 meters for x and 0.84 seconds. So is that, I don't know, I mean, you guys tell me. 3.5, so for the time, right? For the time it falls. Let's do that. Falling time. That's what you said. So how will you find the time? What equation do you use and how do you use it?
Will we use trig for this?
Use what?
Trigonometry.
No, you don't need trig for this.
Chris, I think you're confused about it. So I think you misunderstood it as they're both falling. One's falling from 3.5 meters. The other one's like, think of it as like a car or like a truck going horizontally, like it's on the ground already.
Yeah, I'm thinking it's like a triangle. You see the 3 points making a triangle?
Oh, yeah, I got you. No, like one's falling and then one's just going horizontal. One's not affected by gravity, the one on the ground.
Yeah, so you just have to use equations of motion. It's not vectors. It's not vectors. It's just free fall and constant motion on the x-axis. So how would you find the time using 3.5? 3.5 equals to what? It's free fall. What do you use for free fall to find time?
Velocity times times. Velocity times times. The one that we used before. I forgot the formula. Yeah, GT squared. Yeah. Yeah, because the velocity is at rest, so the velocity initial cancels, right? Because it's at rest.
Yeah. Mm-hmm. There you are. So 3.5 equals to 1/2 times 9.8 times time squared. So time is time 0.84. Is that what you guys got? Because that's what I got from a student here. And that makes sense, to be honest. Yeah, 0.84, right? .84 seconds. So now, like he said, you track it down, you track it backwards to 12. So to find x, since it's the constant speed, distance x equals to speed times time. And that is about 10 meters. If you round it, it's about 10 meters. How about that? Easy, right? Once you realize, look, it's just one step, 2 steps. Any other questions? Or any questions you may have about this?
Could you just scroll up a little, please?
Huh?
Could you scroll up a little?
Like that?
Yeah, thank you.
Okay. While you guys are writing this down, there is a problem I'm gonna do or maybe a couple of problems. Then I'll give you guys a break, and then we'll start with chapter 3. Okay, I will start with chapter 3 because chapter 3 is a follow-up. We're gonna start combining directions, motion in two directions. Okay, so we're still gonna keep talking about motion. Okay, so it's still gonna be kind of like a review of the equation, the situation, but now we're gonna be analyzing what happens kind of like this, vertically and horizontally. All right. Have you guys had any issues with the assignments so far? Assignments 1, assignment 2? Because I think I went over most of the situations on both assignments, so I think it should be clear. All right. Assignment 3 is chapter 3, so that's what we're gonna start doing today. And like I said, make sure that you start getting ready around 8. That's when we're gonna probably start with a quiz. All right. Okay, so I think that should be what is this problem? I found the thing here, I think. If you guys have the Cengage, you have access to all these that I have, right? Problems, examples. So you see, for example, this is one problem I saw today. Oh. Wait. Let's do this. Okay. Yeah, so now it is the there it is. That one. So it says a car accelerates uniformly, means constant acceleration, from rest to 40 miles per hour in 12 seconds. Find the distance the car travels and the acceleration of the car. And the situation is here. So, yeah, how will you do that? You want to find the distance d, and you want to find the acceleration. Be careful with the units. That's why I am giving you this example. So in your notes, you should have the conversion factors that you need. Okay, because you have seconds here, miles per hour. Okay, so find the distance in meters. Find the acceleration in meters per second squared. All right, guys, so come on. What do you do?
I got 239.76 meters.
239. 1.4. Do you do the conversion?
Oh, no, I thought we were in meters per second. Sorry.
Yeah, so you have to convert first. So you have to convert miles per hour to meters per second. So how do you convert this to meters per second?
Multiply 5/18.
Yes, but you have to convert this first from miles per hour to kilometers per hour.
Oh, so you multiply it by 1609 and divide by 3600?
Just 1.609.
Oh, okay.
Because 1 mile is 1.609 kilometers.
Oh, so I got 17.8 meters per second.
Yeah. So 64 kilometers per hour. That's the conversion of this.
Wait,
And
but I
then,
thought we were doing
now
meters.
yeah. And then you multiply by 5/18. That gives you meters per second. That gives you 17 point what? How is here?
17.8? Or
Yeah,
maybe if we can
17.8.
round it to 17.9, that's fine too, I guess. Either one.
That's fine, 17.8. So I want to make sure that this is clear. Who has a question about this? Because this is a crucial step on this problem. If you don't get this, everything is wrong. So who doesn't understand? Who has a question about this?
Where do you get 5/18 again from?
When you do 64 kilometers per hour, 1 hour is 3,600 seconds. And 1 kilometer is 1,000 meters. So that cancels. And then you cancel these two zeros. Half 5, half 18. 5/18. That's where you get this. Okay?
Will we be given that one, like 1.609 kilometers is 1 mile, or will we have to like memorize that?
It's not here. Well, if that's not given, you can always ask me. I didn't put any problems I don't put problems with miles per hour in the exams. Normally the college doesn't do it, but the book does it. That's why I took this from the book. So it should be in the appendix of the book, but you can always write it down, that conversion factor. All right? Yeah. So this you have to write down. It's one of those values that, how can you say it? Hidden, like maybe they assume that it's not used a lot, but sometimes you get problems like that. So that's the final speed. The initial speed is 0. So how do you find the distance now?
You would do 17.8 minus 0 divided by 12. That would get you the acceleration rate. That gets
Yeah.
you 1.49. Then it's 1/2 times 1.49 times 12 squared. And then that's the distance.
Yeah, so how much you go for acceleration is 1 what?
1.49. I got 1.49. 49, yep.
All right. And the okay, that's acceleration. That's part B. And to find the distance, you use what? What equation?
The distance formula, so it's x equals v initial times time plus 1/2 at squared, and v initial 0. So it's just 1/2 1.49 times 12 squared.
12 squared, yeah. That's 72 times that. That's about 100 something. What?
I got 107, but someone checked me because I've been getting everything wrong so far.
I
No,
also
no.
got 107.
How much? Like this? 107?
Yeah. I also had a question. Why do we have to use the one with the acceleration? Why can't we just use the x equals 1.5 times v initial plus v final times time?
You can use that as well. You can use that. Like I can look, you can use what you said. So x or d, right? Is 1/2 v final plus v initial multiplied by time, right? Which is 12. Yeah, you get the same. You get 107.
Why was v final 17.8 and not 40?
Because you have to convert from miles per hour to meters per second.
Oh, right. Okay, perfect. Thank you.
Okay. It's good. It's an easy question, but I knew you guys were going to have questions. The conversion is what gets a lot of students. It's always an issue, the conversions, right? So you have to be careful with that. So it's good that I gave you this to refresh your memory. And also because it is a situation that you're going to face in real life. I gave you an example with gallons and liters, right? As soon as you guys travel to other countries, you are going to have that situation. When I have to buy tools for home, I have issues because I'm used to millimeters, centimeters, not inches and feet. So I have to ask or sometimes to double check, right? But then if you go to another country, they have everything in the metric system. So you have to go back and forth, right? And that's one of the objectives of this course of physics, is to teach you about units, about conversions, and we are using that. Okay. All right. So I want to give you guys a 10-minute break. Let me give you a 10-minute break today, and then at 7:10 we come back to do chapter 3, to start with chapter 3. I'm going to be here, all right, if you guys have any questions. But yeah, take 10 minutes. We come back at 7:10, all right? There. So, to find let's do the y component first for the red vector, which is the same as this y component. So, in a right triangle here, how do you find the y component? How do you find the vertical if you have this magnitude and this angle? How do you find y? Let's label this one, let's label this x. How do you find y?
You can do the trigonometry, right? So
30 times what? Come on, it's a vertical.
Would it be 30 sine 45?
Yeah, 30 sine 45. 15 root 2, so that's about 22.1 something, right? Like 21.15. 21.2. That's this. That's that. And the x component is 30 times what? Times cosine of 45. But sine of 45 and cosine of 45 are the same. So guess what? You get 21.2 as well. So 21.2, 21.2 kilometers. Now, the y component is 21.2. It's the same here, 21.2 kilometers. How much is the whole x component, though, for the red vector now? So how much is the whole thing?
Oh, it would be 41.2.
Yeah, this plus this, 41.2. So now you have the x component and the y component of this massive right triangle. So how do you find the magnitude of the red? Let's call it D. D equals to what? The square root of what?
The x component squared plus the y component squared.
Yeah. So there is square and that square. Is that clear now?
Yeah.
Yeah, that's how you do
Yeah,
it.
thank you.
Okay. So we're gonna do this right now, actually. We're gonna be talking about this. So chapter 3 goes back to the idea of vectors because we're going to be talking about motion in 2 dimensions. And motion in 2 dimensions and projectile motion. And one of the applications is the zero angle launch, but then we're going to do the general one, okay? It's basically this. So what I'm showing you right now is a simulation where you can change the initial speed, the launching speed, and you have here some parameters, mass, which doesn't matter, the size, gravity, we're going to leave it as it is, and we ignore air resistance like we've been doing, and look what happens when I launch. So what do you guys notice about this motion? What do you guys notice? What do you guys see in comparison to what we've been doing so far?
There's an angle, like an x component.
Yeah, there is an angle. Yep. What else? What's the shape of the trajectory?
A parabola. A parabola.
Huh?
A negative parabola.
A negative parabola? Yeah, good. Yeah. So the 2 directions are the vertical and the horizontal direction, right? If I make the angle of 90, this is what happens. That's a situation that we've been discussing. That's just free fall. Well, you launch it and then it goes down free fall. But then we are going to be talking about this. So that is what we know as free fall projectile motion. You still have 2 directions, even though the angle is 0. Why do we have 2 directions? Because you are releasing or you are launching the object from a given height. So it's traveling horizontally as it's falling due to gravity. So it does this type of motion, which is part of a parabola as well, by the way. It's just half of it. All right. So to understand this motion and this one here, right? To understand both, we need our idea of vectors again. All right. No, it's not going to be in the quiz. No, I'm just going ahead right now. This is going to be for quiz 2 for next week. All right. On chapter 3 assignment. So, however, we are still going to be talking about motion because horizontally you have motion at constant velocity, and vertically though, you have the object going up and going down due to gravity. So the object is slowing down, reaches a maximum height, and then it falls due to gravity. So there is only acceleration on the y component, on the vertical. On the horizontal, there is not. So the first thing that we need to review is how you break the velocity into components. Okay? So that's why it was a good idea to do this, because we are going to be using that. So a situation, an example will be this. Yeah, there you are, right? There and there. Okay. So you may have a velocity of, is there on the value here? No, so let's just give it 40 meters per second at an angle of 45 degrees. Yeah, 45 degrees. Let's start with 45. The first step in a problem with, in a projectile motion problem, right, or situation, is to find the x component of the velocity and the y component of the velocity. Okay, you need to find both. And just like we did here, we have to use our vector components. We call it now this Vx and Vy. Vx is constant because there is no acceleration in the horizontal. So Vx is what? 40 times cosine of 45. Vy is 40 times sine of 45. How about that? Right? We're using our components. Now we're using these vector components. If I use a calculator, cosine of 40 is that, times 40, 28.3 meters per second. Okay? And cosine and sine of 45 are the same. Look at it. The same. So it will be the same 28.3 meters per second. So the way you analyze this is that horizontally, if you want to find the distance, which in the horizontal, this distance is now called the range of the projectile. You probably have heard about that in the Olympics when they do the, you know, that the javelin, right? They call it the range. The range is Vx times some given time. Is the time the projectile takes to go up and down. Okay, is the time of motion. So we use this equation for range. It's easy. However, for y, the object is going up and then down. So this is not constant. This is the initial velocity on y. Okay? So one way that we're going to label this is like this. V initial on y. You see that? V initial on y. So that is 28 meters, 28.3 meters per second. Okay. Any questions about this? I mean, it should be kind of a review of vectors, but do you understand where this is coming from? Yeah, so in this situation here, if I have 16 meters per second, and the angle is 447, to find the x component, I will have to do 16 times cosine of 47, 16 times sine of 47. And then you can find the height and the range. And there are more things that you can do, like maximum height, time, right? So that's the first thing that you need to make sure is clear. That you're going to break the value into components, the velocity into components by using sine and cosine. Okay? V sine, V cosine. There it is. All right? So this is important. Motion on X and Y should be solved separately. You have to do the analysis on X and on Y. So that's why we call it motion in two directions, because you are going to be analyzing the motion of this object in two directions. In one direction is a constant velocity. In the Y direction is velocity that depends on gravity. It changes because of gravity. So here are the assumptions, right? We ignore air resistance. Gravity is 9.8. 9.81, we can just say 9.8. So it goes downward. We also ignore air rotation. That's okay as well to ignore. So remember, in the vertical, in the y-axis, the acceleration is always pointing down. Vector-wise is 9.81 meters per second square, or 9.8, negative 9.8 meters per second square. There is zero acceleration on the x-axis. So there is no acceleration in the horizontal. Okay? Just on the vertical. Okay, so we have studied this. This is free fall when you drop a ball. But now you are launching. Look, it's a more realistic situation, right? It's like you launch a ball with some velocity vector in the slanted at some given angle. You still have the acceleration of gravity, but the ball will do this type of trajectory. All right? Okay, so let's show you the basic equations that we're going to use for this. This basically, what's happening here? So this is the horizontal ground, or the horizontal. We have a mass that is going to be launched with some velocity at some given angle. And because of that, it's going to do this trajectory. Okay? Like that. It reaches a maximum height. Let's call it H max. And it also travels a distance, which we call it a range. There. And of course, gravity is always pointing down. So, like I did here, we are going to break the velocity on X and on Y. Now, this is Vx constant. This is Vy initial. So V initial on Y. Vx is the magnitude of V times cosine of the angle in degrees. And Vy is V times sine of the angle theta. Okay, we have those two. Now, I already showed you that to find the range, you just use the distance equals to speed times time. Okay? However, the mass is going to go up and then down. There is a time the mass is on air. Now, to keep it simple, we are going to do this. Time going up, and then time going down. Where the total time is time going up plus time going down. But I'm going to show you, or I showed you yesterday as well, that they're equal. The time to go up is the same as the time to go down. So this is twice the time to go up, if you want. Okay. Okay. The projectile is going to reach a maximum height. On here, the mass is still moving to the right. So Vx doesn't change. What about the vertical velocity? What's the vertical velocity here? At the maximum height?
0.
It's 0. Yes. So at maximum height, at H max, the V final on Y is 0 meters per second. So I can find the time to go up and I can find H. I can find both. Because on Y, I have V initial on Y, which is this. I have gravity. And I have the final So I can use this. V final on y square equals to V initial on y square plus or minus 2 gravity H max or y, H max. At H max, V final is 0, so this is 0. Vy initial, V initial on y square minus 2 gravity, right? So 0, V initial on y, I have it here. V sine theta square minus 2g H max. So look, I found H max. H max is this square, so V square sine square over 2g. So what I'm showing you here is that you can find the maximum height if you analyze the motion on the vertical. Using these equations, the projectile motion equations. V on X, V on Y. Okay? There. You can also find the time. To find the time, we can use this. V final on Y is V initial on Y minus gravity time, or what, plus or minus. But because you are going up, right, going up, it will be 0 equals to V initial, which is this, V sine, minus gravity time to go up. So the time to go up is V sine, the initial velocity in y, divided by gravity. The total time, though, the total time is twice this. It's twice that. 2v sine theta divided by gravity. So you can find times, you can find maximum height. And if you have time, you can find the range. The range is just Vx times time. Total time. So you use this equation and you can find the range. So that's how you do the analysis. You analyze the motion on y, and on x is just this. So most of the problem is gonna come from the analysis you do in the y direction, right? For the projectile to go up and then down. Now, a particular situation is when this angle is 0. Is this situation I gave you here. This here. We call that the 0 launch angle. So instead of doing this, which we are going to analyze, what happens if a person, it's not very realistic. What happens if you do this, like that? Okay? And by the way, there are cases where you have projectile motion, like for example here or here, right? Whenever you see an arc like this, And there is probably more situations where you have motion in two directions. Okay? Projectiles, launching a ball, rocket. That rocket problem that we did last class is more realistic when you have an angle, right? Because we normally launch rockets at some given angle. So we are going to be revisiting that situation using motion in two dimensions or in two directions. Okay? But now let's go back here. So this is a more simple situation, right? If you have a projectile at a zero angle, there is no components for the velocity. It's just horizontally. All right? If you have a situation where you have a mass like this, and this launch, and I'm going to give you numbers now, 10 meters per second from a given height h, where h, let's make it 50 meters again. Let's analyze this motion, all right? Let's analyze the zero launching angle. If you draw the trajectory, it goes like this. Okay. So there is only one component for the velocity, just the x component. Can somebody tell me what is the, if there is, what is the value of the initial vertical velocity?
Would it be 0 vertical?
What? Yeah. Vy initial is 0. So you know what's another name for this? This is the free fall projectile motion, because you have 0 initial velocity, but you have a vertical velocity, which is the reason why it's going like this. Caramba. Here. Okay. So I have the height. I have the initial vertical velocity, and I know gravity. Can I find the time? So let's ask a question here. And again, we're reviewing right now. So it should be a review. So how will you find the time? Can I type here? Let's put here. Find the time for the projectile to reach the ground. How will I find the time it reaches the ground?
Would we use y equals vi plus or minus, no, vit plus or minus 1/2 gravity t squared?
Yep. Vy initial times time plus or minus 1/2 gravity times square. Vy initial is how much? 0. 0. What's the value of y? H, which is 50. 1/2 gravity, let's just use 9.8 times square. So that's how you find time. Right? About 3.3, right? Or 3.3 seconds. Hmm? $3.2. So that's the time the projectile reaches the ground. But now I can ask, find the range of the projectile. Okay. So part B. Ay, caramba. Let's do here. So find the range. All right, so how will you find the range?
You would do the initial speed. Can you scroll up? I didn't write it down what the initial speed was, but it would be the initial speed, cosine, and since it's horizontal, it would be 90 degrees.
0 degrees.
Oh,
Cos
my
0
bad.
degrees.
Yeah. Oh yeah,
Which is
cosine. Yeah.
1. Yeah, which is 1. So it's just 10. It's just 10. Right? So range equals to Vx times time. This is just 10 times 3.2, which is 32 meters. Let's check that. Let's check that. What was the one I gave you? 10. Oh, can I do 50? Ooh, I don't think so here. No, great. Cannot test that. Oh, well. Would be nice to like test that in here, but we cannot get to 50 here. That's okay. That's okay. So 32 meters is the range of the projectile. All right. Any questions? There's more you can do. I'm just showing you the basics right now. The time, we call this the flying time as well. And this is the range. Now you can find the horizontal distance, right? In a motion like this. Let's do let's give you a sort of a challenge right now. What will be the velocity of the projectile when it reaches the ground? So it's a bit more challenging. So calculate the velocity of the projectile when it reaches the ground. And my hint is, remember that it is gaining speed as it falls. Oy. Anybody has an idea? Let's start with something simple. What's the horizontal velocity here?
10 meters a second.
And
How much?
10.
10? Yeah. Because it's constant. What about the vertical? How do you find B final? Ay, caramba. How do you find B final on Y?
It would be completely independent, so you could just do the normal acceleration with V final and V initial. So V initial would be 0. Wait, yeah. And then acceleration is gravity. You have to find time.
No, you already have it.
Oh, yeah, times 3.2, my bad.
Yeah, so you analyze the motion vertically and horizontally. Horizontally is 10. Vertically, you do the free fall. Okay. B final on Y is V initial on Y plus gravity time. This is gaining speed. V initial on Y is 0. Gravity is just 9.8. Time is 3.2. That's like 32, 31, right?
Yeah,
Yeah,
31.36.
6 or 4.
31.4
Yeah.
meters per second. Yep. So let's repeat. So now we have this situation. 31.4 downwards. 10 horizontally. How will you find the resultant? How do you find the total V?
Did you do the Pythagorean theorem?
Yeah. Yeah. So V is the square root of 31.4 square plus 10 square. So
I
31.
got 32.95, so 33.0.
Yeah. 33.0 meters per second. There you are. So the projectile reaches a final velocity of 33, like this. Okay. That's how you analyze free fall projectile motion. Okay. Any questions?
Yeah. So if instead of using the velocity final equals velocity initial plus acceleration times time, what if we use the formula velocity final squared is equal to velocity initial squared plus 2 times gravity times height? I got a different value when I did that. It was similar, but I got 29.8, whereas the value for the other formula we get 33.0. Is it just? It might have been a miscalculation on my part, but should the answer be the same?
Yeah, V final square, V initial square, 2 gravity times height. No, that is 31. free. What gravity do you use? What height do you use?
I used 50 for height and 8.91 for gravity.
It's 9.8. Gravity is 9.8.
Oh yeah, I got it confused. Thank you.
Okay, you get the same. Mm-hmm. Okay. Additionally, since we're talking about two directions. Okay, so there's a question about the quiz. I made it so in the open-ended questions you can upload a picture. Let me know if like I'm gonna be on the Zoom, so if it gives you an option, let me know. All right, for the open-ended questions, there should be a way to upload pictures or work. All right. So yeah, for the open-ended, you should be able to type or upload. Yeah. Yeah, you should be able to do it in an iPad. You should be able to do that from there. Okay.